Bismillahirrahmanirrahim. Now let's think this way. You want to compute Ito integral from a to b of sine of b sub t db sub t. So you have sine depending on Brownian and you want to compute its integral with respect to this. For this we also need simplest version of Ito lemma, but if we look at the Ito lemma, it says that our f b sub b minus f of b sub a was equal to integral from a to b of first derivative of function at Brownian minus plus 1/2 a to b second derivative at Brownian dt. So we need this integral, function depending on Brownian with respect to Brownian. This is the expression that is helpful. Now what does this mean? We need a function whose derivative is sine. So what is the function whose derivative is sine? So you need to be thinking in the first calculus course. So if our function f of x is equal to sine x, then what is the function whose derivative is sine x? So it's going to be the minus cos, or maybe minus cos. If you take minus cos, again you can work out. If you take only cos, because plus minus will not make that much difference. So of course if you take f of b sub t to be, let's say, minus cos so the function whose derivative is sine is cos. Yeah, all right, we are right, because the derivative of this function is going to be sine, because cos is minus sine, so minus into minus plus, so minus cos is derivative sine. So this is going to be suitable function. If we take this function, then this integral will become integral of sine. So let's before apply this Ito lemma, let's compute the first derivative and second derivative of this. So first derivative is going to be, of course, sine beta sub t, and then second derivative, which is again going to be cos beta sub t. Now we just will substitute these values into this expression. So let's do that. So f of b sub b minus f of b sub a equal to a to b first derivative at b sub t dbt plus 1/2 a to b second derivative dbt. So f of x is equal to sine x, or f of beta is sine, f of b is sine b. So this is going to be sine of, no, cos, minus cos, sorry, minus cos of b sub b, and then minus, and then again minus cos of b sub a is equal to a to b. And we know that first derivative of the function that we chosen function was, don't forget that function was minus cos of b sub t. So this is the function over which we are applying this simplest Ito lemma. So this is going to be sine b sub t dbt plus 1/2 a to b, and the second derivative is cos of b sub t dt. Okay, so after a simplification, we got that a to b sine of b sub t dbt to be equal to cos of b sub a minus cos of b sub b minus 1/2 integral from a to b cos of b sub t dt. So this is going to be the expression for the Ito integral of sine depending only on Brownian. I hope that makes sense. So if you want to find out the Ito integral of any function that is depending on Brownian, then you need to know what is the function f whose derivative is g. So you need to find a function whose derivative is g. So you will compute this function by roughly integrating like calculus in one variable. So once you know what is your f, then you will apply your Ito lemma onto this function and you will ultimately get this. Thank you.